right, so there's something interesting that you've hit on, that it always does stay a pentagon. What is a pentagon? Like, can you tell me, like, how would you define a pentagon?
It's a polygon with 5 sides and 5 inside angles.
Okay, and what's special about the sides?
They're convex sides.
No, just the actual sides themselves of a polygon.
They're all straight lines.
Yeah, they're all straight lines. So there's something kind of surprising that happens here that you might not have thought initially would be true. But it seems like straight lines in this inversion actually stay straight lines. Which isn't obviously the case, right?
But yeah, you invert the shape of the pentagon, but you don't invert the lines.
Yeah.
Both sides.
Do angles stay the same, do you think?
No. Because...
Well, I mean, here you can see that the angles are definitely not they're definitely not all the same here.
Wait. Do they? If you...
It looks like they are different.
It looks like the angles are not being preserved.
Yeah. Because here it's almost a right angle.
Yeah,
and then here, kind of there.
Okay, yeah. So there's some strange things. So let's add like a lot of sides and almost make it a circle, our shape. So let's see what happens when we do that. So click on it and then up arrow.
This is almost a circle.
All right.
Well, it's a smaller circle. And so
Okay.
it just gets bigger.
All right. So
I see. What?
so there's another surprise of a shape that stays the same.
The circles are preserved.
It looks like circles turn into circles.
Circles stay circles.
Which certainly
Well,
wasn't obvious either.
that kind of means the angles stay the same, because this is like 28 gun, and the angles
sort of see the sides.
The angles are staying the same for it to be this shape.
But I mean, they might be distorted a little bit.
Yeah, but you can't see them because they're so small.
Yeah.
Well, actually, the angles are really big in here, but.
So it's interesting. So this sort of reflection or inversion has lots of fascinating properties. Lines stay lines, circles stay circles. We're not sure. It doesn't look like angles get preserved.
Just do it down a lot.
Yeah, see now I'm gonna go down to a triangle.
Triangle.
Yeah, angles. Like here, angles are definitely not preserved.
Yeah. So it doesn't look like angles get preserved. But there's lots of fascinating properties about this, and it's just a really simple idea.
What happens if you go down? You can't go down more than a
Oh yeah, he must have set it to be.
You can't do like lines.
Yeah. So is there any other surprising things that you've noticed while playing around with this?
If we go back to the almost a circle.
Okay.
Just keep doing this. There. I can make these almost.
So we
can put them like almost on top.
Yeah, and when you made the square be the same thing, it was actually on the center.
Yeah.
Which
But
you know,
now,
we said it was shading the wrong side, but that's all right. So here it's not on the center.
Well, if I make it on the center, it still will be the same as our other previous shapes.
Right.
I do it like
It seems to wrap in on itself.
yeah.
Okay.
But this.
Yeah, what do you think's causing?
That
Oh.
looks like a straight line.
Oh, interesting. You found a situation where it doesn't look like the circle stayed a circle. The circle appears to have turned into a straight line.
Maybe it's just so huge that it looks straight here.
Well,
Remember
oh, shoot.
Oh,
I was going to say don't touch it.
I can get
What
it.
do you think's going on here? What's geometric thing is happening right in this situation?
The circle.
Maybe the circle's really, really big right now.
Okay, what would cause that to happen, to make the circle really, really big?
Well, you have to get really, really close to the edge of the circle for the reflection to get big.
To the edge of the circle? What do you mean?
Well, what? Actually, right now we're not, because when you get the circle close to the edge, the reflection gets
Which
bigger.
edge? What
The
edge? are you
edge
talking-
of this circle. The reflection gets bigger.
I'm not sure that's right, because here I can be really close to the edge. I mean, I'm touching the edge even.
But
So what's causing it to turn into a straight line?
so what makes it get really big?
Well, all the points would have to be mapped on this line somehow.
Yeah. Okay. And what would cause that to happen?
Let's see.
Where does that line go to?
It would have to go to infinity.
Okay. So what happens? What's going on with that circle on the inside? What point goes to infinity?
Well, the center of the starting circle.
Okay. So what's happening here?
So that means that we must be touching that point.
Ah.
Mhm.
When our circle touches the center, it seems like we get a straight line. Is that a circle?
I don't think so.
Maybe it's a circle that has infinity in it.
That's interesting.
Interesting. Huh? So we did find one other thing.
Yeah.
This is pretty neat. It's a fun little program, and this is a side of geometry that you really don't see in school that much.
Yeah.
It's called inversions. All right, good work, guys.